Það komið í sæl og verið velkomin á morgunverðarfund hjá Opin kerfum. Davíð Þór Kristjánsson heiti ég og hérna forstöðumaður yfir lausna- og ráðgjafahópi innan sölusviðs Opin kerfa. Fyrirlestrar okkar í dag þeir koma úr ýmsum áttum. Fyrst það Jesper Brísling frá Fujitsu. Hann ætlar aðeins að kynna Fujitsu og bjóða alla velkomna. Næstu tekur til máls hans Jónas Rantilla. Hann frá Fujitsu líka og hann ætlar að leiða okkur í allan sannleikann varðandi gagnageymslu og afritunarlausnir frá Fujitsu. Fujitsu hefur verið samstarfsaðili Opin kerfa til margra ára og stimplað sér rækilega vel inn á íslenskan tölvumarkað með sínum tölvu- og PC-lausnum. Fujitsu hefur einnig í samstarfi Opin kerfi útvegað háhraða reikniklaustera fyrir stóran þýskan bílaframleiðanda sem hýstur á Íslandi og í þjónustu í Opin kerfum. Ég ætla ekki að nefna neinn nöfn en fyrsti stafurinn BMW. Og eftir Jónas kemur svo áhugaverður fyrirlestur frá Klaus Meyer Allendorf. Hann kemur frá Violin Memory. En hann mun fara í gegnum það lausnir sem fyrirtæki Violin hefur upp á að bjóða, en Violin hefur getið sér gott orð á flash storage markaðinum. Þannig að ég ætla ekki að hafa þetta mikið lengra frá mér og ætla bara að opna fundinn og afhenda honum Jesper Brísling. Jesper, the floor is yours.
Well, first of all, my name is Jonas Rantele. I work for Fujitsu. I've been working for Fujitsu for close to 3 years now. Previously, I was working with another American brand company selling storage. I work in the role as an evangelist, whatever that is. But that's my title at least. So don't worry, we won't be doing prayers or anything. We'll be fine. But I will talk a little bit about our vision and a little bit about strategy with Fujitsu when it comes to storage. First of all, I want to tell you a little story about a customer in the Baltics. It's a bank, and they sent out an RFP, and they got all the answers right from all the different vendors, and they were looking through this. They were going like, okay, HP, EMC, Dell, Fujitsu. Wait a minute, Fujitsu, do they do storage? And some analysts says that we are the best kept secret in the industry, right? That Fujitsu actually does storage as well. But we've been doing storage for more than 40 years. So we're not new to this, because we've been building mainframes for more than 40 years, and we're building a storage to our mainframes. And actually, in Japan, we are number one. We're the biggest storage vendor and manufacturer in Japan. And we have a fantastic growth. In Europe, we grew 42% year over year, which is remarkable in an industry that is not growing that much percentage-wise. We introduced the third generation of our returners line now in 2014, and it was very well received. We've actually been overwhelming customer feedback. Everybody has been really, really happy with our new S3 generation. And it's interesting to see that also the analysts now are starting to pick up. DCIG had made a survey for mid-range unified storage. So mid-range unified storage, and number one is NetApp and NetApp. Okay, I'm not surprised. I mean, they've been doing unified storage since Dracula was a boy, right? But we actually managed to take position 3, 4, and 6, and 7. And I think that's pretty good, because number 6 and number 7 is with our entry line. That's our entry. And we make spot number 6 and 7 in the mid-range test. That's pretty impressive. So what we've been known for all the time, Gartner says that customers who value stability and investment protection should consider Fujitsu storage. We are known for our reliability. We have very, very high quality on our hardware. A customer case. We will look at Bijou Brigitte, which is a ladies' fashion store in Germany and all over. They have more than 1,000 outlets, and they needed to protect their storage, because if the storage is down, everything is down. They're hosting it on Microsoft Hyper-V, the servers, and they were using their own scripts for the storage, for the failovers. And of course, with scripts, it's slow, It is a manual process to write the scripts. It's error prone, right? You get something wrong in the script and it doesn't work, and so on and so forth. So they were looking into buying a virtualization solution, either SVC or vPlex, what they were looking at. But then we came along and they showed them a briefing of our solution, which is called storage clustering, which is not the virtualization. We'll talk a little bit more about this later. But in virtualization, you have virtualization servers between your servers and your storage, right? That are caching and that are separating the storage from the servers. In this case, we don't do that. In this case, we have the software running on the storage controllers themselves, and making sure that a LAN from one storage controller can fall over to another storage. And this is completely transparent for the servers. So we're getting to do this with a fraction of the cost compared to a full-blown virtualization layer. And we don't get an additional management. It's the same management, right? You don't need to learn anything else. And they bought a DX500, which is the mid-range system, and they're really happy with the solution and the availability of the solution. Another happy customer I have, and I just found out yesterday that this is going to be a really, really bad example. Is anybody using TomTom? Why not? Exactly, they don't have map over Iceland, which I found out when I came at the airport. It's like, maybe this is the wrong example, but in the rest of the Europe where it actually works, they have something called traffic prediction, right? Where they try to guide you to the right road depending on how much traffic there is. And they're doing this by they're buying in the data from the cell phone providers. And I think this is pretty cool. So they can know that on this highway we have 1,000 cell phones and they're traveling at 5 kilometers per hour, right? At this side road, I have 50 cell phones and they're traveling at 100 kilometers per hour. So it's time to take the people off the highway and onto the side road again, right? To do this. But to be able to do this, and this is for the whole of Europe, right? They need to have some pretty fast storage. So a number of years ago, they sent out an RFP. We were shortlisted. We were three vendors on the shortlist. But they didn't stop there. They said, but you need to provide us with one of these storages. So all of the vendors had to provide storage. And then they ran their database on this. And by a clear margin, we were the fastest one. So they just said, okay, let's go with the Fujitsu. This point, it was actually, at this point, I believe that there was not even a pricing discussion after that. We had done an initial pricing, and they just realized that this is what they had to have. So they were really happy with the solution. And now, last year, they bought, what they did buy back then was a DX8400, which is the enterprise, the biggest model we had, the biggest and the baddest. But now, when they did this again, they actually found out that our mid-range, the DX600, was fast enough for them. So they bought a DX600 instead. This time around, there was some more price haggling, but what can you expect? But they're really, really happy with this. So we are really, really fast with our solutions. Another fast solution, and this I found interesting. Siemens, they needed a storage for their SAP HANA databases, and they were using 2 terabyte chunks, and they had a lot of these chunks, and they needed some really, really fast disks to drive this. They've been trying out the NetApps, and then we supplied them with the DX600 and 480 disk drives. So these were not SSDs, they were regular SAS drives. And when we had 23 gigabytes per second in throughput from the disk, and 144,000 IOPS with 30% write and 70% read, random. This was 144,000 IOPS from disk and 440,000 IOPS from cache. And this was 10 times faster than the NetApp. So this I like, right? They beat us on the theoretical test on the analyst, yes, but when it comes to raw performance, they didn't beat us. So let's have a look at our mission in storage. It's quite simple, actually. We need to provide a flexible management and storage of the data, and we need to have some protection around it. That's it. What more do you need? Pretty simple, isn't it? Well, then something called reality comes in, right? And you need to consider what clients do you have, what databases have, what about your security, what about your growth rate, what about everything, right? Well, this is only part of the reality. There's another part of reality as well. Are there laws and regulations? Do you need to keep the data for 10 years? Do you need to throw it away after 3 years? How about the physical location? Do you have enough in your data center? Do you have enough cooling? Do you have enough electricity? Do you have enough floor space? And not least of all then, budget, right? Can we afford this? How much does it cost? So to juggle this board here and make it even, customers are using this, and I'm sure you all are using at least 2 of these. Well, we consolidate, we virtualize, and increasingly more and more we want to go for automation as well, to make it as automated as possible, less man hours to manage it, saving cost that way. So if this is what we need consolidation, automation, and virtualization. That puts some requirements on the storage. And I put this as cogwheels. We need to have 5 cogwheels for this to work. If we consolidate, if we put all of the eggs in the same basket, then it needs to always be up. Back in the old days when we had 1,000 servers running one application each, if one server was down, only that application was down. Now if the storage is down, everything is down. That's unacceptable, right? So everything always needs to be up. It also needs to be scalable, because if we're building everything in, then we need to scale, both from a performance perspective and from a capacity perspective. It also needs to integrate with the virtualization softwares that we're using. It needs to be simple and it needs to be smart. So let's have a look at our offering. If you're looking at the first one, scalability, the Fujitsu storage scales in 3 dimensions during the life cycle. First of all, capacity. But everybody scales with capacity, right? You can buy 1 shelf and then you can have additional shelves, right? That's true. But we scale a lot from a capacity. And the thing here is that I mentioned before that we've been doing this for 40 years, but there's one thing that is unique to Fujitsu and nobody else does. And we'll talk more about that later also. We have 1 storage family, right? Looking at EMC, they have the VNC, they have the VNX, they have the VMAX, they have their etc. Looking at HP, you have the MSA, you have the left hand, you have 3PAR, and so on and so forth, right? They have multiple, depending on, is this an entry level, is this a mid-range, is this a high-end? Then we're looking at different brands, different solutions. But in the Fujitsu case, it's the same brand, it's the same family from entry to enterprise. So you can start with a small box that you can expand with 5 shelves. If you grow out of that one, you can do a head swap. Keep the disks, no data migration, yes, a downtime, because you need to recable it. But then you can just grow, and then you have a bigger model, and you can have 11 shelves instead of 5 shelves. And then you can go to 22 shelves, and then you can go to 44 shelves. So you can really scale. You can start with the storage with two disks and end up with something with 2,000 disks. And that is something nobody else can do from a scalable perspective. But it's not only about capacity, it's also about performance, and this is also a difference. The Fujitsu storage has always been very fast. Talked about this before. And the thing here is that we have a lot of backend in our storage. A lot of channels, a lot of capacity in the backend. Looking at the system, a competitor system with 100 disk drives, if you scale much over 50, you don't get any more performance. You don't get any more IOPS. You only get capacity. But in our case, we scale to the last disk drive. So when you put in disk drive 100, or if it's a big system, disk drive number 2000, you still get a couple of more IOPS out of the system, because we have enough backend channels to really work with this. This is true for SAS drives. Talking SSD drives, yes, we will be full a lot before that, right? Because SSD drives can deliver huge amount of IOPS. So looking at SSD drives, the smaller systems takes about 28 SSD drives, and then you bottle out what the system can do from a performance perspective. Then we only get capacity as well as you grow, right? But that's true for SSDs. Then, of course, we scale on an SLA perspective. We can have different type of layers, different type of disk. We can have encryption. Encryption, by the way, I think that's rather interesting. We can talk about that now. We support two types of encryptions. One is the self-encrypting drives. Most other vendors support this as well. So then you buy a more expensive drive, and then the encryption is on the drive. It's the same speed as a regular SAS drive. There's no difference, but they cost a lot more. But we also have encryption in the actual software on the storage, on the controllers. And you don't need to pay anything for this. It's included in the operating system. Because we have the same operating system from enterprise to entry. Meaning, if you buy our storage, the cheapest one, 4,000 euros, you get the encryption if you want to, right? If you need to. And more importantly, with the self-encrypting drive, who has control over the data? Well, you have, and NSA, right? Because they have the keys to this disk as well, I promise you. But in the case of the software on the controllers, you have your own key management server, you have the keys, we don't have them. Which also means that if you lose somehow your key management server and you don't have a backup, the only thing we can say is, sorry, because there's nothing we can do to help you, right? So you better make sure that you protect your key management server. Because there's no backdoors. That's the downside. You don't have any backdoors, right? It's your data. You can also do a lot of different interfaces, SAS, iSCSI, fiber channel over Ethernet. We're going to come out with InfiniBand, and so on. It's a lot of different interfaces. And we also have built-in true quality of services built into the system, also for free. It's part of the enterprise software suite. You don't pay anything extra for that. Looking at the interface, it's very simple to work with. It looks and feels like a Microsoft management console. There's actually a YouTube video on this as well, if you want to have a look at the management software. So you can have a look to see how it works. So you can either use the web GUI straight into the storage controller or onto the server, the management server. You can also, of course, use scripts, so you can do a command line as well. And everything is built in a way that you should be able to handle everything during daytime. You can rebuild your RAID sets while they're being used. So for example, if you have well, this is not a so uncommon scenario, an application owner comes to you and say, I need really fast performance for this application. Okay? You give them a RAID 1.0 with a lot of these drives, and then you realize after half a year that they're not using this. They're not taking these IOPS here. They don't need a RAID 1.0. A RAID 5 would be fine for them, right? So basically, you wasted 10 drives here. But what you can do then is you can actually say that, okay, I want to rebuild this into a RAID 5 group. And you can do that on the fly while it's still being worked on. So you can transform a RAID 1.0 to a RAID 5 while it's being used. Which is pretty cool. Smart, yeah, we have a lot of different tools, management wizards and so on to make it easy to work with. We also have many modern features. SIM provisioning and snapshot is built in, comes part of the operating system. We talked about quality of services, is also part of the operating system. We have different levels of quality of services. The quality of service that is built in is the quality of services where you strangle machines. So you say that this machine is behaving badly, is trying to take 40,000 IOPS, but it should only take 1,000. And then you can say this one has a maximum of 1,000 IOPS. Works fine. However, if you have a lot of different servers, it's going to get rather complicated. Because you need to keep track on how much do I put on this server, how much do I put on that server, and so on and so forth. So after a while, it gets a bit complicated. And then that's when we came up with something we call automated quality of services, last bullet point here, is where you turn the whole concept upside down. And instead of punishing the bad machines, you say that this is my database server. It needs 1 millisecond response time. And then it gets 1 millisecond response time. So in the background, the system will throttle all of the other servers to make sure that this server gets the 1 millisecond, or 5, or 10, or whatever you put as a requirement for the server. So this makes it really, really easy to work with. We also have protection against data rot. What do I mean with that? Well, this protection is two parts. First of all, we always store everything with parity. So when you're writing a 512-byte block, we actually store a 520-byte block, so 8 bytes extra as parity. So when we read the data, we check the parity, we recalculate the parity, and we check, is this the same? Yes, then it's the same data out as it was in. However, this only works for data that you actually read. And there's a lot of data on your systems that haven't been read for 2 years, 3 years, 4 years. But you still have them there, and you don't want to get rid of them. And in that time frame, there's a probability that you have gotten a bit error. And 1 bit error, that's fine, because that we can correct. But what if we got double bit errors? Well, you're running RAID 5, no, you can't fix that, right? Because you have 2 blocks that are bad. So in this case, we also scan the blocks that has not been read. So all the files that haven't been read for a couple of years, we're reading them anyway, just to check the parity and check that they are not corrupted. So making sure that your data is consistent over time. So all of these bullet points, well, the first half, cache, thin provisioning, quality services, data rot, and encryption. All of those comes with operating systems. There's no license fees for those. Then, of course, we can do replication, we can do automatic storage tiering, we can do automatic quality of services, and also integrates with automatic storage tiering. These are paid-for licenses. And then we can do storage cluster, which I mentioned before, also a paid-for license. Yeah, that's the storage cluster. We talked about that. So it's completely transparent failover in the case of a system failure. And it works with replication, and then on top of that, the storage clustering. We integrate with Microsoft Hyper-V. We support ODX, VDS, VSS, snapshots, and so on. Of course, we integrate with VMware. We have support for VII. We have thin provisioning support with space reclamation, VASA, vCenter Operation Manager. vVol. How many have heard about vVols? Hand up. Only 2, 3. Okay. My point of view, I think this is the most exciting thing from a storage perspective, and hypervisors are coming out. Have a look into it, because what this is doing is changing the way that VMware works with storages. Now, as it is today, you provide a LAN, and from that LAN, on that LAN you store, that's going to be transformed into a disk, right? And on that disk you store your VMDKs. Meaning you have multiple virtual machines stored on the same LAN, right? If you take a snapshot on the storage controller, you take a snapshot of the LAN. Meaning it's a snapshot of all these 5, 10, 20, whatever machines you're running on this. Is that what you want? No. So today, when you're taking snapshots of virtualized environments like VMware, it's the VMware servers that are responsible for the snapshots, because they take a snapshot on the individual server, right? So we're not using the snapshot effect on the storage today, because it doesn't work. But with vVol, it's going to be different. With vVol, on the storage side, you create a pool, and you say, here is an area where we can store vVols. And then on the VMDK layer, we create something called a vVol, which has a counterpart in the storage pool. And now, all of the virtual machines have their individual defined storage in the backend. But you don't need to define it. You define it once, this pool. And the rest is then done by VMware automatically. So this means that now, if I take a snapshot, I can take a snapshot only on the machine, right? The virtual machine. And this is then done from the storage controller side. Same through replication, same about quality of services, and so on and so forth. It's really, really exciting. It's going to simplify for VMware administrators a lot how they work with this. And yes, we support this from the beginning. So day one, when VMware version 6 comes out, we will support this. Of course, we also integrate with SMIS and other vendors, Citrix and so on. I need to check the timing here, because I have a 1.5 hour presentation that I'm supposed to deliver in 1 hour. So If it's going too fast, just approach me afterwards and I will tell you more about some things if I miss some things. Well, I mentioned mainframe before. It's designed for mainframe. It's designed to always be on. So we have an effective real-time operating system. And what do I mean with this? Well, it's very popular to talk about Flash, and we will have somebody to come here and talk about Flash before, right? And what is important with Flash? We can ask Klaus here, he will tell me. Who needs 1 million IOPS? Nobody. Who needs very low latency? And I will say everybody, right? So that's what the game is about. And with an effective real-time operating system, you can reach low latencies. So in the SPC benchmark, our systems have shown that we can do 0.6 milliseconds. Looking at Dell Compliant, for example, right? They have, with the same type of SSD drives, they have 3 milliseconds response time. And I go like, what the? What's going on, right? They have 5 times slower response time, same disk drives, operating system, right? You need to have a fast real-time operating system, and we perform well even under full load. So this is at 100% CPU utilization, we have 0.6 milliseconds in latency. Of course, hardware is very reliable. We share the same quality of services assurance as we have on the mainframe. All the systems are designed to have 5 nines of uptime, and that's the 4,000 euro entry-level machine as well, because it has the same operating system. It's made in the same factory, it's made in the same line as the higher ones. So we have a really, really good quality on our machines. We don't outsource, we build everything ourselves. Has anybody of you been to the factory, by the way? No one? You need to take them. Where are you, Frederick? You need to take them to the factory. Yeah. I think at least I like it because my father was an engineer, and when I was a little kid I always went to my father to the different factories and so on. I like doing factory visits. I think it's interesting to see how everything is being manufactured, and the point is that we don't outsource. We don't do child labor in Korea or China or whatever. We build everything in Germany. Our workers have, all of them are, if they want to of course, can be members in the union. It's not a problem. They have a good salary. I don't have the particular slide in front of me, but they have a good salary. I believe it was 2,700 euros a month in salary, and so on and so forth. Maybe I am swearing in church now, but HP has their factory in Czech Republic, right? Their workers do 500 euros a month, and they're working 12-hour shifts. And that's 500 euros is if everything is going well. In fact, they're making so little money that the people in Czech Republic, they don't work there. They import people from Mongolia and from Vietnamese people to work there, right? Going over to the Fujitsu factory in Germany, right? They have a 35-hour work week. If we need them to work on Saturday, we have to tell them on Thursday that, yes, you need to work on Saturday. And then if for some strange reason a lorry truck drives into a ditch or something, we don't get the parts we need, so we can't manufacture on Saturday. Then we can't say, sorry, you have to stay home. We don't pay you. The fact is that we promise them work on Saturday, meaning we have to pay them on Saturday. So then the workers got 2 choices. Either they come in and we put them on whatever work we can, or they can stay home. If they voluntarily stay home, then they don't get paid, right? But it's their choice then. So we promise them work, we will deliver work. So it's quite a difference on how the working conditions are for the workers as well. Call home functionality, of course, we have that on our storage. So this is the cogwheels then. We can always be on, we can be scalable, we integrate with the virtualization software, we're simple, we're smart. So let's look at the lineup then. So in this picture, I have 3 different fields. I have the entry level, the DX60S3, and this is really, really entry. This is a little bit on the side, and the reason for that is that it cannot replicate. It can only be the one-box solution, it cannot replicate. Starting from the DX100, we can replicate, and we can replicate with everything. So DX100 can replicate with 200, 500, 600, or an 8700. So why is the 8700 then separate? Well, it's the S2. The Enterprise is still one generation behind. So at the end of, after summer, we will be releasing the new S3 8700 series. And we will be introducing an 8900 as well. So that's interesting in the point of view that it's the same operating system, meaning I can replicate natively from an entry-level box to an enterprise box. And we can do this in generations back. So the DX100 can replicate with the 8400. Remember the one that TomTom had, right? That's an 8-year-old machine. They can replicate with each other because it's the same software. Different versions though, but same software. We also share not only the same software, we share the same type of disks, and we share the same type of shelves. And that's why we can do this head swap that I talked about. You can start with the DX100. If this then completely full, then you can swap out the head and make it a DX200 instead. And if that one gets completely full, you can swap out the head and turn it into a DX500, so on. So you can really scale from bottom up. Performance-wise, we are #1 in spec marks. Not spec marks, sorry. SPC1 benchmark, I should say. We're #1 when it comes to latency. The DX200 has 0.63 milliseconds latency. The DX600 has 0.61 milliseconds latency. The DX8700 has the top test for megabytes per second. That's the SPC2 benchmark. We also have an extremely high MTBF. MTBF for the systems is 1.5 million hours. That's 171 years for the systems. And the enterprise has slightly more, up to 217 years. I already mentioned this too many times, but I want to have this slide anyway. We have different type of shelves, of course. We have 3.5-inch shelves, 2.5-inch shelves. We have high-density shelves. That's what 3.5-inch drives take, 60 disk drives in 4 use, sorry. And you can mix any type of disk drive. You can mix SSD, SAS, and the nearline SAS in the same chassis, not a problem. We're also unified. We talked about this before, right? We did very well in this benchmark, in this survey. We are truly unified. There's not a server on top of the storage doing the NAS part. It's not a VMware inside and running 2 different operating systems. No, in the same operating system, we support both NAS and SAN at the same time. Another thing that I really like about Fujitsu is the licensing model. I will give you a scenario. It's not so uncommon, actually. You bought a system, 50 terabytes. You have, I don't know, whatever, 100 disk drives. And then you need to expand this, right? You need to have another 10 terabytes. You need to buy another 20 disks. So you go to a storage vendor, you buy this, and they say, oh, fine, here's the price for the disks. And by the way, now that you have more than 50 terabytes, you need to have a larger cache on your controllers, otherwise it's not supported. So then you buy the most expensive 8 gigabytes of RAM you ever bought, right? For 2,000 euros or whatever, 20,000 euros, whatever. And then they say, oh, now you have double the cache size. Now you need a license for the cache, right? Oh, and by the way, I see that you're using automatic storage tiering, and now you have 60 terabytes instead of 50. We need to have a more automatic storage tiering license. And you need to have more replications license. And by the way, support is per disk drive. And per terabyte of automatic storage tiering, the support for that as well. So on and so forth. It gets very, very complicated to know how much it's going to cost me to scale, right? Because I don't know that. In our case, we don't have that. All the licenses are based on the controllers. So if you bought a DX200 and you bought it with 5 disk drives, you bought replication, you bought automatic storage tiering, you bought storage clustering, so forth. Start with 5 disk drives. This one can take 264 disks. You can scale it to 264 disks. You can replicate, you can do whatever you want. You have the licenses. So you buy it per box, and then you're fine. So that's really one really, really big difference. It means that it's very predictable to grow. And now I'm on thin water here, because now I'm in a different country, so I don't realize that this might actually be different. I'm going to talk about support. So you need to jump in here and stop me if I'm lying. Yes, question? What I mean by? Tiering, yes. Well, tiering is sorry, I didn't go through that. Well, automatic storage tiering is about that you have a fast layer, SSD layer, you have a SAS layer and a nearline SAS layer. So 3 different types of disks, fast, normal, and slow, right? And slow also means cheap and high capacity. And with automatic storage tiering, the system itself can move data between these layers to make sure that the data is being used often is in the SSD layer, and data that you haven't read for a year is in the nearline SAS layer, right? So yes, inside of a LAN, yes. So a LAN is exactly. So so basically what you're doing is you're creating a, first of all, it's getting technical, but you create pools. So you say that these 20 disk drives, they are my SSD pool. So here I have a layer of SSDs. And here I have 50 SAS drives, and they have a layer here. And then I have my nearline SAS, 20 of them or whatever. And then you slice from this pool, you slice a LAN. So you say that I want a 1 terabyte LAN. It's sliced out of this pool, right? The whole pool might be 100 terabytes or 200 terabytes. So you slice a LAN out of this. And then that LAN, depending on the traffic pattern of the LAN, maybe everything is residing in the nearline SAS layer because nobody's actually reading this LAN. Or maybe everything is on the SSD layer because it's a database and it's being accessed all the time, right? So this is the purpose here, is to move it between the layers. And if, well, of course, it would be better if we did like, well, it's moved. So if we're going to go for all the SSDs, right? But there's a cost associated with that. And maybe you don't want all SSDs for your data that's really old data, right? So to make it cheap, you're going to go with cheaper disk drives, and you have the software to move it between, right? That's a paid-for license. That's a paid. Not the tiering. Well, if you want to have it automatic moved between, that's licensed. But of course, you can create your own teams. If you know that this LAN is the database LAN, you can put that on the SSDs, and you can say that this is a LAN that I want for my backups, to store my backups. You can put it on. Yes, if you want to have it within the LAN, that's a license, and we call that an automatic storage tiering license. But that one is based on, as I said, it's based on the box. So you can add the disks to this without additional cost of licensing, right? You only pay for the new disk drives. And when it comes to support, it's the same way. We have the support on the shelf. So when you buy a shelf and you have maybe 8 slots left that you haven't used, then you can just buy disks and put in, and they will have support already. Because support is for the shelf. True? Yes? Good? It's different because Fujitsu is a very flat organization. It's another thing. Now I'm talking about Fujitsu, not the storage. We are not a very hierarchical company. When I was working at the old company I was working for before, the American company, if we needed to do something special for a customer, maybe we had done a complete mistake or whatever, we needed to give them something or do something, right? Then the sales rep had to ask the sales team manager, that talked to the country manager, that talked to the European manager, that talked to the manager over in the US, and then all the way almost up to the CEO level, depending on how much or little money it was, right? And then all the way back down again. But Fujitsu is a very flat company. Denmark is controlled by Denmark, right? And Sweden by Sweden. We don't need to ask. If we want to do something in Sweden, the Swedish country manager, yes, we do this. Also, if you join us in the Fujitsu forum we have in November every year, it's a big showcase down in Munich, down where we have close to where we have the factory. You can have sessions. You can sit down and talk to our developers, to our product managers. So if you have a showcase saying that, I have this special case, I want to have this type of storage, I want to integrate it this way with this software running this and this and this, and I see that we have these issues. The product managers, they want to talk to you. They want to know about this because they want to change and they want to fix. So it's very short distance between the field and the development, right? In American companies, typically it's the other way around. Development develops something, right? And then marketing is going to tell you what you need, right? Tell you what you need in your business, right? But we try to do it the other way around. We try to say that, what do you need in your business? And then we say, okay, now we know that there's a lot of customers requesting this now, okay? So that gets prioritized. Of course, we have our own list, right? These are the things that we know we want to do. But in which order we do them, that's where you can come in and influence as a customer, right? This one I talked about a little bit already, but I think this is interesting, the ability to replicate between different machines. And it's not so uncommon that you buy 2 expensive high-end machines for your production system, and then you want to buy a small test system on the side. But you want to take production data over to the test system, right? What about if this production data is your Vmaxes and then this is a VNX? They can't replicate natively, right? So you have to have some software on top of this to support this. But in our case, you can have a DX8700 that replicates to DX100, for example. So not only are we optimized for automation, virtualization, and consolidation, but we also have leading performance and price performance according to SPC benchmarks. I already talked about this, the factory, a little bit, but we also have a very, very good lab down in the factory. In fact, it's so good that some of the German car manufacturers, there's one starting with a B and ending with a W, right? 3 letters. But we're not supposed to tell who they are, so I don't do that. They come to our lab to test electronics in the cars, because we have one of the best labs in Europe for these type of things. I mentioned before the SPC benchmarks. These are 2 machines. We got the really, really good results. DX200, 200,000 IOPS, and this is what's interesting is doesn't sound so much, right? Yes, 200,000 IOPS is a lot, right? But you need to remember it's difference on how you calculate and how you do. This is IOPS in a real environment, in a real test. This simulates database, a mail server and file server at the same time. It's 40% writes, 60% reads in this test. Just doing a simple IO meter test, a DX200 does approximately 750,000 IOPS, right? But when it boils down to real reality, that's only going to deliver about 200,000, right? So when some competitor says that, oh, our system, we can easily do 200,000 IOPS, and then you need to say SPC benchmark, and if they say no, then you know in an SPC mark, those 200,000 is going to be 30,000, 450,000, whatever, significantly less at least. So that was 45 minutes on the storage. Now I have 15 minutes left for the data protection. And I'm going to talk about something we call the CS800 and the 5th generation of that, which is a backup to disk with the application. Good thing, 70% of your downtime of your system is planned. Bad thing, 30% isn't. And of those 30%, 80% of those comes along with data corruption. So in 24% of your downtimes, you have data corruption. This really means that we need to look at the better at the backup. And the typical pain points is that the data is growing really, really fast. We have multiple copies of more or less the same data. The time to take the backups are shrinking, right? We don't have enough time to do this. We want to have a number of concurrent backups. Looking at the tape perspective, why is this important or not? Depends on the software you're running, the backup software you're running. Some of them can do multiple streams into one tape drive. Some can't. TSM, for example, can't. So they can only take one server to one tape station at a time. So the solution is, of course, go to backup to disk, because it gives us a very good backup performance. You can have parallel backups. You can do restore and backup at the same time. But the problem is that it has a not so good price performance, right? It's rather expensive. So the solution is to go with the backup to disk with the duplication. And the duplication is the ability to, basically you're looking at blocks, and if you have similar blocks, you create a database. Oh, this blocks look like this. It's the color blue, right? Do I have any more blocks that are blue? I have here, 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 here. Then instead of storing all the data, I just have a pointer saying that this is a blue block, this is a blue block, this is a blue block. And then I saved the blue block at one time. And then I have pointers saying that this is the block should be here, 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 here. In this case, you can get a reduction, very good reduction of the data, at least 10 times. Well, I shouldn't say at least. Between 4 times and 40 times. Typically around 10 times the duplication rate. Best case scenario I've seen is 44 times reduction. That was a huge VMware environment. Worst case was 3.9, and that was a TSM solution with the duplication turned on. So even though they were using a software duplication, we still managed to shrink it down to 1/4 of the size. Why go with an integrated appliance instead of going with some sort of software to do this? Well, of course, everything is tested, it's optimized. We optimize the systems and have the redundancies that we need and so on. So looking at the CS800 then, the duplication. So what it means is that we have multiple blocks of data that all looks the same. And there's different ways of doing this. You can do the duplication at the source, meaning at the server that you're doing backup. Then you're putting load on that server, right? Because then there's a software algorithm running there. You can do inline the duplication. In that case, you do the duplication when it comes into the backup appliance. And this is what we do. We do it inline, which is good because then we have this full speed all the way. Some of them, the first generations, they did post the duplication, meaning that we took the data as it was. And then, afterwards, we tried to look for similar blocks. But then, of course, we need to take the full backup first, and then shrink it down. And then we take the full backup, and then shrink it down. So we need more disk space in that case, right? If you can shrink it when it comes in, that's better. There's also something called hybrid duplication. We support that. It's where you can do some of the work on the client side, so on the source, and then some of it in the backend. The benefits, you can have extreme reduction of data, you have faster backups, and you have cost savings. There's 2 other things to consider when you're looking at the duplication. If the duplication is working with fixed block length, we can see here that I have some data. A, B, C, and D are the blocks that I have. And you see that they are all unique, so I need to save all of them. What happens if I get a block shift? I put in a byte first in the block here. Then all of my blocks gets shifted, right? So A is now starts here and ends here. B starts here, ends here. C starts here, ends here, and so on. This means that all of a sudden, I've gotten 4 completely or 5 completely different blocks that I need to save because they don't look the same anymore. What we do in the CS800 is we have a variable length of the block size. So the problem here is like insert 1, you change all. If you have variable blocks length size, we put in a new block, new data in the first block, we just decide that, okay, block A should now be 5 instead of 4. So, of course, A gets shifted into E, but B, C, and D remains the same. So this is a lot better in the duplication ratio. You get a lot more duplication out of this instead of the fixed block length. So here's a slide that explains a little bit about how the duplication works. I can see that I have blocks that are similar. I save one each of these blocks, and then I just need to remember the sequence. To put that file in, I need a red, I need a green, I need a yellow, I need a blue, I need a purple, orange, and green, so on, right? So that's how it works. On top of this, we also compress all these blocks. So we not only deduplicate, we also compress to get the best of it. So the duplication is really good when you have a lot of static data. Data is not changing that you're taking backup on. If you have many full backups, if you have similar backups, like in a VMware environment where you have a lot of operating systems, they have a lot of same files, and if you're running daily backups. Why is it not good for yearly backups? Change rate. So from one day to another, there's only a small amount of data that is changed, right? So most of the data is the same, meaning I get a very good duplication ratio. But this year's backup, from last year's backup, a lot of data is going to be changed, not so much is going to be the same, so I get less of a duplication ratio. So generally speaking, this is true for all the duplication appliances or softwares, is that the duplication ratio gets lower as the data gets older, because it looks more different. It gets higher if you have the same type of data. If I'm taking backup of 50 Microsoft servers, right? That's going to be a higher duplication ratio. If I take backup of one Microsoft server, it's going to be low duplication ratio, right? So the more files I have that are the same, the higher it's going to be. So variable block length size, good for us. We also have compression, it's good for us. And we also support very large block pools. And what do I mean with this? Well, the duplication is only inside the box, right? So if my box only can store 50 terabytes, when that is full, I then need to buy a new box, right? And there's no deduplication between these two boxes because they're an island in themselves, right? So therefore, it's important to know that we can have a large pool of the capacity. And if this is not enough, we have actually a CS8000 as well that can do even larger block pools. This is a higher enterprise class style backup. We start, well, not start, but we can support up to 13 terabytes per hour. And this is really leading in performance looking at this. Of course, there's other ones that can do more, but in completely different price range. We can do more as well. The CS8000 can do at least 150 terabytes per hour. But you need to add a 0 or maybe even more on the price, right? So the CS800S5 is simple, flexible, and very low TCO. It starts, we have two different models. We start with something we call the entry. The entry is, to begin with, a server with internal disks, and we support 4 terabytes. With the duplication, it's going to be anything between, I don't know, 16 and 80 terabytes, right? Depending on how much duplication ratio you go. Rule of thumb, about 10 times is a good rule of thumb. So approximately 40 terabytes worth of data can be stored in that 4 terabytes. Then you can scale that in increments of 4 terabytes. You can scale about 4 more in the server, or additional 4 more, 4 more, 4 more by adding a extension JBOD shelf to it. So maximum 24 terabytes. We support NFS, CIFS, We support virtual type libraries, so we have multi-protocols. We support OST from Symantec. We have all the different interfaces, 1 gigabit, 10 gigabit. We also have fiber channel, of course, for VTL support. And we scale from 4 to 24 terabytes. Once again, when it comes to licenses, it's in the box. Here, everything is included. You don't need to buy any more licenses. You have the licenses for NAS, for replication, encryptions. Everything is included in the speed. Is what we call the hybrid, the duplication. And the backup performance is 5.5 terabytes per hour. Then we have another model which we call scale instead of entry. In this case, we start with a server, but there's no disks in the server. Instead, we have something called the DX80. Am I lying now? It changed, right? It's a DX200 now. Anyway, it's one of our storage devices, right, that we talked about previously. And we know that the storage has very good performance, it has very good reliability. So we can start with either 16, 24, or 32 terabytes, and then you can scale in increments of this up to 160, 240, or 320 terabytes. Same multi-protocol support, same type of interfaces, different, capacity, and also here all the software and licenses to go along with the software are included from the beginning. And here we have a performance of up to 13 terabytes per hour. So it's based on our proven servers and storage, right? We have redundancy for the HBAs, for the RAID controllers, fans, and so on. We have hot disk as an option if you want to. We, of course, since this is a true storage behind, right? I talked before about the protection against data rot. We saved everything with 8 bytes extra parity. We read the blocks that haven't been read to make sure that they're correct. That's called data block guard and so on. We also, of course, the cache is protected and everything. So what makes us unique is that we are very easy to really use the hardware performance potential, right? Because it's optimized from performance and capacity. And we have very good TCO with a flexible configuration, simple upgrades. We can also have a path to tape, meaning, remember, the yearly backup, should that be on the application device? What did I say? No, it should not, right? Because it doesn't have so good application ratio. So what we can do here is we take the backup daily to the backup appliance, and then the backup software can just tell the backup appliance, give me a copy to tape, and then we will create a full copy to tape, not from the server, but from the backup appliance, straight from the backup appliance to tape, and then we have our yearly backup that we can save away, or monthly, or whatever it is, right?
So, welcome. If I speak too fast, because I only got 30 plus 5 minutes, let me know. And I'll be around today and tomorrow until lunch. So any question we can take during this or afterwards. My name is Claes, and a lot of names. I'm what we in Denmark call a third-generation refugee. I have a German mom and a half Swedish-Danish father. So Danish citizens and don't really speak any of the languages very well. I'm what we very called a regional sales director. It's a very, very nice title, very low salary, but I cover the Nordics, Baltics, Benelux, and what we call Central Europe. So that's around 45% of Europe, which is my territory. So, does anybody know anything about violin before I start? Anyone heard about one? Thank you. Thank you for visiting the website. So violin was founded 10 years ago, and we have our own Gartner Magic Quadrant called all flash arrays. So we invented the industry of all flash arrays. So over the last 10 years, we've been pretty busy. we did something, or our founder saw something that most of us will get used to eventually. So we do storage based on Flash. That's not something special today, but it was very, very special 10 years ago. So we are a storage company selling enterprise storage, just happen to be based on raw non-Flash and not an SSD. And you can come get the story afterwards, because this is a 3-hour story on itself. So today, we have been in the industry for 10 years, and by that we have helped a lot of customers. You will see familiar names. You will see very, very large customers. We have another slide deck with smaller customers that is more Nordic. So we normally have a reference in any industry, no matter what you want to do or want to try. We have tried it before, so we can share the customer learnings with you before you start. So this is our legacy. There's not an industry we don't deal in, and there's not an industry where we don't have a major or more major accounts. And most of these customers have been customers from the very beginning, and remains customers today. So we do have broad reference base. Our vision is transforming the data center from disk to Flash. But why do we do it? Some of us is old enough to remember the punch card. Not a lot of us, but we heard about it. After the punch card, you're laughing. After the punch card came tapes. Everybody remember tapes, but most remember them from backups. But they used to be the primary storage media. After tape came Flash. After tape came disk, 15, 20 years ago. Today, disk is changing to another thing as primary storage. Next thing is Flash. Everybody have a Flash product. So that's the change in storage media, and that's what we've been driving for a while. So Juniper is just an example customer, is one of our public reference customers. They saw this very early, and they changed their 8-floor tile infrastructure to half a rack, which is very, very good marketing. But what's in it for them, which is the important part for customers, is that they saved a lot of money. We were not cheaper in buying, but over the 5 years they were doing the TCO, we were cheaper. And that's why they changed. Now they only have one tile floor they have to pay for. All the details are in here, and you get all the slides afterwards, and any details you want, you can get. There's nothing secret in our company. So, what is primary storage, and where are we? We see 3 things, and Jonas mentioned it also. Performance, and he said nobody needs 1 million IOPS, and nobody does need 1 million IOPS. Some customers actually need more than 1 million IOPS. But IOPS is not performance. Latency is performance. So Violin started in the performance area. We were the fastest, and we were the first one to be fast on storage. 1.5 years ago, we moved into the data protection. So all the data center services you normally know from storage, replication, all of it was there. We didn't have that until a year ago, and we were the first mover to have it when it comes to all-flash array. But we were expensive. But we have introduced, a couple of months ago, the next generation, and Jonas talked about one operating system, which we have, the 7th generation of our operating system, which includes all data reduction services you will need, or might need, if you want them, which means that we will be price competitive. So the perfect vendor for most customers is in the middle, no matter the size, no matter the media, but it has to be a balance. And of course we're there. At least that's how we try to present it ourselves. So what is that we do? We do enterprise flash. We do it without compromise. So record-breaking sustained performance. And I smiled when I know Jonas. We've been doing a lot of these tours, and I smiled when he said latency around 1 millisecond. In our world, 1 millisecond is slow. But what does it do for you? Not really anything, except it can save you a lot of money somewhere else in your stack. So what we normally do with our performance is saving licensing on server and database licenses. We cannot save you any money. We don't have a value. We don't have a value proposition for you. But normally, we can save you licenses. And those running Oracle Enterprise license, I used to work for Oracle for 3 years. They run around $47,000 each. Save 10 of those, you have a good weekend. So we do it with a full suite of enterprise data center services. What do I mean by that? So that's any replication service you want, synchronous, asynchronous. That's bidirectional, it's long-term, it's metro cluster, it's stretched metro cluster, it's replication within, it's mirroring, it's continuous data protection. Not many vendors have continuous data protection and continuous data replication. We do that. All included in the product we deliver. So inline data reduction, what's that? Jonas mentioned it on his backup slide. It's the ability to shrink or deduplicate whatever you have. So deduplication is good for some workload. Anyone ever tried to deduplicate a database? Doesn't work. So you compress your database, and by that we're able to shrink whatever we have, wherever you have, into a very, very small footprint. Those of you who are a little technical know that 3 unit is about this size in a rack. So what we do, we are able to shrink our box is 3 unit high, around 200 terabyte into 3 units, and by that get the effective cost per gigabyte around $1.50. Normally, that would go for disk, will be a pretty good price, but this is all flash. So we're fully redundant, we're hot swappable, all the things you would expect from a storage vendor, we do this. We have one single pane of management, and I will come back to that. And we're non-disruptive in the scale from the small solution to petabyte. So we scale non-disruptively from around 7 terabyte to above 1 petabyte, if you would need it. So we're designed for a lot of things. We're designed for physical workloads. A lot of flash vendors today do application-specific things. We want to deduplicate your virtual environment. Okay, and then what? We do multi-workload installations, so we put everything you put on your normal storage, we put on Flash. Flash for us is not an important thing. Your environment is a storage environment, and that's how we do it. So we do cloud workloads, virtualized workloads, we do big data. So we consolidate all your primary workload on a tier 1 platform. If you have tier 1 storage today, we will help you replace it and save money. Ease of management. Any normal operation should be handled within 3 clicks in our GUI, and it's possible. 3 clicks, you're done. If it takes more than that, you clicked one of the 3 clicks wrong. There's a command line interface you would like to, but we do it in a GUI because it's much easier to do daily operations on a GUI. We do all data services LUN by LUN. So a lot of vendors in this market will say, we do deduplication, it's always on, it's fantastic. So what if you put your database on a deduplicated version? It doesn't work. You just use resources trying to deduplicate something that can't be deduplicated, which is a database. So we have the ability to turn off and on, LUN by LUN, deduplication and compression. So if you need it, if you want it, if it makes sense for your business, you can have it. We also have businesses that runs deduplicated for 28 days a month. And for the last 2 days, when they do their monthly billing run, they turn it off, so they have the full performance. I won't touch on the re-rate. We have a patented way of doing things inside the box. I don't have the very technical slide back here. I can touch upon it if you want to. But we have around 400 patents pending and delivered within the flash industry. So we are the leaders in this. We have something we call pay-as-you-grow licensing model and expansion for non-disruptive upgrades, meaning that we ship more than you purchase, and you can upgrade on the fly. It's a 30-second operation to upgrade capacity in these boxes. For you, it's just seamless. For us, we think it's a value add. I think we already end there. 99 point some nines uptime. Is this important? What's the difference between the 5 9 and 6 9s? 12 minutes a year. For those of you that have the need for this, you're very commonly have 2 data centers or 2 replicates of your data already. We will cover that too. Everything within the box is redundant. What does it mean for you? It means that if something fails, and it's mechanic, something will fail eventually. We've been in the Nordics for 4 years. 3 of these have failed in 4 years, so they will fail. But everything is replicated. Everything is redundant, so no matter what happens, your business on the box itself will continue to run. If something fails, we will break and fix it on the fly. Either within 4 hours, within 24 hours, depending on what kind of service contract you will have. We deliver any kind of service contract you want, anywhere you want it. And I mean anywhere. We do have the ability to do it with helicopters in remote areas. For instance, on Iceland, northern part of Sweden, northern part of Finland, northern part of Norway. We do it by helicopter if customer requires it. So, we also have what we call advanced data protection services for Zero, RPO, and RTO. So that's the ability to switch over from data center to data center or replica to replica without the host noticing it. We call it stretch middle cluster, a feature that some of our competitors do have, most don't. So from the host perspective, it will be totally non-disruptive if a data center falls out. So, in our world, this is what it takes to build the best all-flash array. 10 years of development, a box, one single operating system. Thank you, Jonas, for pointing this out. So whatever we do, it's the same operating system that goes in any device we sell. So this is our uniqueness. This is our intellectual property. We developed all of this over the last 10 years. I know Jonas talked about wages in Czech. We don't do anything in Europe. We don't do anything in Asia. Everything is built in America. We're an American company. We build and ship this out of America. We have our research and development in America. It's very important to local American companies that it's done on American soil. So we're California-based with a large European operation. So, why not SSDs? Jonas just embraced it. Why not SSDs? Any guess? Those of you that remember the tape, when we moved to disk, remember it was 2 different form factors. Disk could do something that tape couldn't. So we had a new form factor. It was a new media. So when flash came around, the fastest way to implement this was to use the same form factor as disk. That's why SSD was made. 10 years ago, everybody said to Violin, you're insane spending money developing something like this. But what is flash? Flash is memory. What is this? This is very advanced DIMM. So that's our differentiator. So somebody else told us why not SSDs. So Micron, they do flash, they do SSD. But they say that treating solid state like a hard disk is not using the full potential. Storage Mojo, a lot of you guys that have a little technical background will follow the site and say, it's opportunistic. It's something in between. Everybody will move to raw flash devices eventually. Solid state is just something we have for a short period of time transiting into flash. You don't do things on a solid state because you cannot control what happens within solid state. That's in the technical slide deck. On the flash, you can control what happens. Flash is not easy. That's why it's important to be able to control it on the smallest granularity level. And this is very important. The current interface on solid states are the SAS bus, but it's not fast enough. So every vendor, and I think there's around 7 vendors of SSDs, are moving away from the current backplane, which is SAS, to PCIe. So over the next 2 years, any investment you make in solid state today have to be redone because the manufacturers of the solid state are moving away from the interface you're buying today. Please consider that when you consider your next solution. So, what are we good at? I normally say that we are very good in specific industries. So I normally say we're good in banking. We're very, very good in retail. We're good in telco. We're good in most industries, but we have some very good references in telco. This is a Nordic customer, and I think they're owned by a company called Hutchinson. They're called High 3G, and in the Nordic countries, the telco is just called 3. They started when the 3G was out, so it happened around 10 years lifespan. So I was part of the project when we closed it this last fall in Sweden, had their Nordic headquarters there. And the issue was basically that the Oracle wasn't fast enough. And fast is a soft thing. It's fast for me might be slow for you or vice versa. But for them, it meant that whatever they did when they did their billing run, it's taken 28 hours to do it on some very, very large systems, 4 racks each, replicated. And the consequence was it took around 28 hours. Is that important to the business? It get the invoices out? No, but the important thing was those 28 hours, a lot of other people was infected or impacted by the slow performance of the storage system. On the same storage system that PeopleSoft people resided, they were waiting for 1.5 days. All the research and developers on the same system were waiting 1.5 days, doing nothing every month. So they start calculating how many hours was spent waiting on the billing run. So we did nothing on the Oracle part. We only moved from one platform to another. And 3 did a very, very thorough proof of concept. They tested 9 vendors. They spent 4.5 months testing everything they could find. They tested, of course, first of all, the Oracle Exadata. This was an Oracle issue. It was out in the first run. And they tested, I can't remember all of them, but they're willing to talk to you about it because they tried everything. At the end of the day, there were 2 vendors that had all the features they needed, including the high availability. And when we got the order, we didn't even know how fast it would be. When the slide was made, it was 3 hours. They're down to around 2 hours now because they have started tweaking Oracle. But without doing anything else, they got to reduce the billing cycle from 20 hours to 3 hours, meaning that they could do it overnight. So no PeopleSoft people were impacted, no developers. A lot of other people just got it faster. After this, they also moved their anti-fraud system, which is very important to telcos. Have to be able to check any transaction if you want to. It's on the platform. They moved their SaaS to this platform, and the SaaS people come around and say, "What have you done?" I said, "We moved you here." So after a week, they moved them back on disk using VMware. I said, "Now you go find the money to have your own array." So all in all, we're very, very, very good in telco. We have around 10 larger telcos in Europe alone as reference customers. So some of them are billing, some of them are Oracle, some of them are SQL. But as I said, if we cannot make a business case for you, if we can't save you money or time, which is money, we will not offer you anything. So, any questions? I haven't brought a lot of other slides on reference customers, but we have a slide deck if you want it. So what do? We do this box. If it looked the same for the last 4 years, it's a box. It's black. There's no fancy on it. But we do everything. It's all about capacity. What do you need and how much do you think you grow? So where do you start? You can start small. This is actually not 11. It's down to 7 terabytes now. So from 7 terabyte up to plus 1 petabyte. We can scale. It's the same operating system, runs on everything, so we can scale them, we can stack them. If you want encryption, we have an encryption version, so you can just stack the encryption in it. We always say below 1 millisecond latency. In a mixed workload, not in the pissing contest where everything is designed to get a good number, but in the real world, maybe a 70-30 read-write ratio, which is more than close to normal. We do sub-millisecond latency on anything we do. We normally say that in a pissing contest, we do around 300 microsecond. And we have faster than that. But it only makes sense to your business. If you can save money somewhere else by being fast, that's when we have a proposition for you. So we have a, what do we got slide? We got application consistent snapshot. Is that important? Yeah. So if your billing platform is running virtual and you have your database in some VMs and the application in another, you have to have a snapshot and a copy for backup that is consistent. Otherwise, your backup is worthless. Thin provisioning, we do have it. It's part of our code. we don't think it's important anymore. We think we have data center services today that are more important, like compression and deduplication. We have clones, thick and thin, asynchronous replication, consistency groups, continuous data protection, inline data reduction, and WAN optimization. What's WAN optimization? It's the ability to shrink whatever data you send across so you don't have to rely on your bandwidth but still get things across. The inline data reduction, Jonas had a slide on how to dedupe. So 2 years ago, we didn't have deduplication. And everybody have deduplication today in some version or another. And you find a thing that everybody builds on the same idea on how to deduplicate. Deduplication for a customer is unique. So if your deduplication is 5-to-1, it's 5-to-1 on any vendor. I have to be honest. It's the same. If you have EMC today or HP and they can do 5-to-1, everybody can do 5-to-1. There's no magic sauce that somebody can do 6-to-1. That's not how it works. Deduplication was originally founded or invented by a company called Stockton. Stockton was sold off to a company called Falcon Store 10 years ago. But the guy, Steve Dalton, that invented Stockton, works for us. So our implementation, it was the original people that invented deduplication 10 years ago. So we are not worse, but we will do the same thing for you that anybody else would do. But we have it. And we have it from the original people that wrote the original source code. So if one box is not enough, if you have more than 200 terabyte, you might have, you can start stacking them up for a larger solution. So in here, you have all this, plus the ability to do stretch meso cluster. Stretch meso cluster is spreading your data across 2 sites and do it transparent failover between the sites for the host. LAN mirroring, sync replication, non-disruptive scale up to 6 arrays. Today 6 arrays. A year ago it was 4 arrays. We have tested 10, and when customers start asking for it officially, we will have 10. But it's not important because we will scale very, very far, and we can support today's arrays, last year's arrays. 5 minutes. Because it's the same single source code everything inherits from. Got that. So, management. I like this. We do have on site, on our website, we have a demo so you can go in and see it. We just released the 3rd version. Everything is built on HTML5 for those interested. So it apparently are fast. But basically it gives your administrator a personal look and feel on anything you have. You can have control of any violin array you have from one pane of glass. You have one interface. You have 10, one interface. We have customers having hundreds of these arrays, one interface. And then your daily operation of doing everything by 3 clicks becomes very valuable because you don't have to waste 15 minutes on something you can do in 30 seconds. You basically can design one view for your database guys. They can have their own view. One view for storage admins, one view for network guys. So everybody can have their own login and get their own view, like pulling widgets down. It's very, very powerful. And we do have customers, that's our proof of valid, is that we have customers asking us, when will you support our other legacy storage? And we won't. This is designed for Flash. And Flash is different than disk. So everything we do is designed for the raw Flash. The pay as you grow basically means you can start small and scale. So we will ship you either half box or full box. And you can scale, non-disruptive. And it's a little like Oracle in the positive thing, is that you can just use it. We're not like Oracle that we will come and give you a fine for using it, because every array we do call home for service purposes and tell us that now you have to start using more capacity. If it's an error, we talk about it. This is the Nordic. We don't fine people for trying. But if it's something more consistent, we just have an agreed upgrade price on taking more capacity into usage. To my knowledge, nothing happens by accident on a storage array. A LAN don't create itself. Normally people are involved, but people do make errors. And if errors occurred once, it's fine. We normally have a route that says anyone that have used more capacity that they have already licensed get a call from the sales guys, not from the support guys. So we always take it case by case. So for us, it's a no-brainer. We do everything on Flash because that's next generation media. It's been for a while, but everybody's moving to Flash very rapidly now. It's all performance. We do any workload we have and then do it with sustained performance. It's all workloads and it's the lowest cost. This is a bold statement and we are ready to test it. So, I'm ahead of time. If you have no other questions, I'm done 3 minutes ahead. So I will be here for the next 27, 28 hours. Any question, let me know. Take my card. We use Fujitsu as our partner here, but you're very welcome to have any questions direct. I will just lead them back to you. So, thank you.
Mér langar að þakka ykkur öllum fyrir að koma og hlusta á mjög skemmtilegra fyrirlestra og þið getið verið hérna áfram og tala við fólki beint og við segjum þessu bara hér með loki. Takk fyrir.